Okay, so to continue with the Lab 3 recordings, let's go ahead and run step 4, the proc univariate code with the graphics requests added, and let's see what the graphics look like. Hold on 1 second while I run this. Oh, let me try again. Okay, now when you run that histogram statement, SAS puts that histogram up in the foreground as soon as it's done running the code. And it's tempting to start working with the data already, but we should always check the log window. Let me click on that and make sure that the code did not result in any errors or warnings. And you see that step 4, all I got was a little note saying how many seconds it took, no errors or warnings. Good. So here's the histogram. What do you think? Looks like a pretty symmetric picture to me. Also, notice that if I were to draw in the outline of the histogram, it actually looks like a bell-shaped curve, and that's going to be important for us. Things like that, observations like that are going to be important for us coming up just in a couple of weeks or so. Bell-shaped curve would be the outline of this picture, and it looks pretty symmetric, doesn't it? That idea coincides with the skewness statistic from the proc univariate output that we've already seen. The skewness statistic was 0.23, very close to 0, indicating relatively symmetric data. Alright, so that's the histogram, and of course you could make more observations about this, but I'm going to move on. What about the other two plots that we asked for using the plot option on the call to proc univariate? Those can be found in the output window. So let me go to the output window, and since we ran proc univariate again, actually you get all the same statistics again that we've already talked about, but down past those statistics, SAS gives you the stem and leaf plot. Let me scroll down so you can see that a little bit better. Gives you the stem and leaf plot right here, and it gives you a box plot right here. Alright, so the stem and leaf plot, we've seen examples of this before. You know how to interpret it. SAS gives you a little legend down at the bottom telling you how to combine the stems and leaves back. You multiply the stem dot leaf by 10 to the power of -1. Wow, so 10, the smallest leaf down here at the bottom you start off with 10.0, but you have to multiply that by 10 to the -1, so basically divide by 10. So that's actually an albumin level of 1.0. This stem and leaf, if you look at the outline of the stem and leaf, again, this outline mimics the histogram, and that's the whole point of a stem and leaf. It's like a histogram, but you've got data values instead of bars, and so if you wanted to dig a little bit deeper into particular data values and find medians and things like that, at least roughly, you could do that with a stem and leaf plot. Histograms make that a little bit more difficult. Okay, SAS next to the stem and leaf plot tells you the number of leaves that were in each stem. That's this middle column where my mouse is hovering right now, and that also will help you count, say, to the median if you wanted to. We're not going to do that here. We already saw the median up above in the output. And then you've got the box plot to the right. And you know how to read a box plot. I think the only thing that's new here, or might be new, is the plus sign. Do you see that there's a little plus sign right in the middle of the box there? Well, that plus sign is the sample mean. The line across the middle of the box is located at the sample median. The sample median. And how do you know what the value of the sample median is? You actually have to read all the way across, folks, all the way to the right, all the way to the left. Read the scale on the stem and leaf plot, read the stems, and that gives you an idea about what the median is in the box plot. So it's a little bit inconvenient, but it's there. It's not that bad. And then I guess that's about it. Nothing else much to say about the box plot. We're going to discover ways of producing much prettier box plots a little bit later on. Stem and leaf plots, this is it. This is all you're going to get. And that's okay, because we usually don't publish stem and leaf plots. They're just a tool for the analyst to stare at the data and discover interesting features. You probably won't publish a stem and leaf plot, but you might at some points publish some interesting box plots, and so you don't want them to be crude little ASCII text font figures like this one. You'd want them to be higher resolution graphics. We'll learn how to create those in a later lab. Okay, one last part to this demo that I want to go over, and that is performing descriptive statistical analyses for categorical variables. And let's just keep it very simple right now. Let's pick a couple of categorical variables. For example, in step 5, we're picking patient origin as one variable and methicillin as another variable. Okay, and since those are categorical variables, take my word for it, they are. How do I know? Well, I know because I've looked in the data set. And when you perform step 2 on your own in the lab session, you'll also learn a little bit about the variables patient origin and methicillin. And one of the things you'll learn is that they're categorical variables. All right, great. So if they're categorical variables, how do we describe their distribution? Remember, it's pretty easy. You just create a frequency table showing how often each category occurs. It's as simple as that. And the procedure to do that in SAS is called proc-freq, F-R-E-Q, the frequency procedure. Again, you call proc-freq and you tell it which data set to work with, just like proc-univariate. You have to have the data equals BIOS500.Milton option on the call to proc-freq. And then for proc-freq, you need a statement telling SAS which variables you want frequency tables for. It's not the var statement in this case, unfortunately. SAS requires the tables statement. Tables. Alright, so you say tables, and then patient origin, and methicillin, and you run. Alright, simple enough. Let me go ahead and run this. And there's the table. Pretty straightforward. You get a column for frequency, you get a column for percent, you get a column for cumulative frequency and cumulative percent. Those are uglier columns that we don't often use, so we'll get rid of those in the next demo, in the next part of this demo. But we do use frequency. Look at that. The methicillin category 1, whatever that is, and step 2 in this exercise will tell you what that means. That occurred 170 times. Category 2 for methicillin occurred 208 times. And then you've got the percents that those frequencies represent out of the total number of times the variable methicillin was reported. A value for it was reported. By the way, the total number of observations on methicillin is 378. Actually, I said in step 2 you'll figure out what 1 and 2 mean for methicillin. Actually, the little label here at the top of proc-freq tells you what 1 and 2 mean. 1 means meth-resistant Staphylococcus aureus, and 2 means not resistant. Okay, there we go. Oh, I forgot patient origin. Similarly, patient origin, there were 2 possible values, 3 and 4, meaning what? That patients either came from nursing homes, it looks like, that's what 3 means, or they came from their own home. And it looks like there should be one other category 2, which means they came from another hospital, but that doesn't seem to have been a value that was ever used in our sample. All patients came either from nursing homes or they came from their own home. 50 patients, in fact, came from nursing homes, and 328 came from their own home. Pretty easy to read these frequency tables. Let's get rid of these cumulative frequency and cumulative percent columns. They're just running totals. Let me highlight them here. These columns, they're just running totals of the frequency and percent columns, and sometimes I find them to be handy, but most of the time I ignore them. So how do you get rid of them? You come down, you repeat that proc-freq code. So here we go. In step 6 we've got the same code, but what you do, hold on, I've lost my mouse for a minute, cursor for a little bit. Okay, you repeat that code, but what you do is you put an option on the table statement. So you put a slash on the table statement after you've listed the variables, and then the option is nocum, N-O-C-U-M. So slash N-O-C-U-M has to appear before the semicolon for the table statement. Nocum, meaning hide those cumulative columns. If I just run this, you'll see what happens. There are those same frequency tables, but with no cumulative or running total columns. Okay, that's it for these recordings.